Ready?
Yep.
Okay, so we're in 1.3, talking about a thing called angles and standard positions. So we did some stuff with angles from our geometry days in the past. Trig is going to do the angles in a lot more specific sort of a way. What they're going to want is for us to, when we draw angles, always draw them in standard position. So they want the vertex at the origin. On an angle, what's the vertex? Here's my hands making an angle. What's the vertex of the angle?
Where the two rays connect.
It's the point where the two rays meet, sort of right there. So when we draw these angles, we're going to want to get them positioned in such a way that the vertex is always on the origin when we draw them. Then they're going to have two sides. There's a thing called the initial side, which we'll draw first, hence the name initial. And then there's another side called the terminal side, which is the other side. We're always going to draw the initial side on the positive x-axis. What do I mean by positive x-axis? Where's that headed? Here I am at the origin. I want to draw it on the positive x-axis. I'm headed
To the right.
to the right. So there's the initial side of my angle. Every single picture would start off drawing that. So I'm not even going to make you draw that. I'll do a longer picture first, and then we'll streamline the picture slightly. But we have our vertex on the origin. We have the initial side on the positive x-axis. Then if I want to do a positive angle, I'm going to head counterclockwise. Where does that mean I would go if I'm going counterclockwise from here? Up or down?
Up.
Up. If I want to do a negative angle, I'll start to head clockwise, meaning down. About where would 45 go? Where would a 45 degree, if I wanted to complete this as a 45 degree angle, it's positive, so I'm going clockwise. How far would I go to find a 45 degree angle?
Halfway between the positive x and positive y.
That's correct. Because if I did this as my initial side and I went to terminal side there, how many degrees is this?
90.
This is 90. I'm going to go 45, so I'm going to go half of that. So that would be drawing myself an angle in standard position. Vertex was at the origin, positive x-axis is guaranteed, and then it's just a matter of figuring out where the other side should go. If I had gone right on top of this, we just decided that would be 90. If I went right on top of this, where would I be? How many degrees of rotation would it be if I got to there? 180. What if I drew a side down here so that I rotated that far? .270 is correct. What might this number be? 360. 40. So if I didn't go anywhere, you know, that's sort of a shared numbering scheme. Let me label the quadrants just to make it easier to talk for the next couple questions. I wouldn't draw that much on any picture, okay? If this is my homework paper and I'm going to draw 45, I'm just going to go like this. That's all we need. Okay, we know the other side's on the x-axis. We just need to figure out where would 45 be on that map. Question about plus-up. So if I go to do 320, where would 320 be on the map? Which quadrant would locate me at 320 degree angle?
Quadrant 4.
Quadrant 4. Closer to 360, closer to 270, about in the middle.
About in the middle.
About in the middle. It would be a tad closer to
360.
360, but not by much. Okay, so 320, we're good enough with that. So what we're trying to describe is, from the start, we've rotated 320 degrees in that positive direction. Like a full spin is 360. We went almost a full spin, we're just a little bit short. You don't have to draw the big squiggly line, I'll erase that. But that's what we're trying to basically describe is how much rotation have we got. I assume you've all probably heard of like doing a 180, like changed your mind and went back the other way. You know, that's what's going on here. We started here, we did a 180, or do a 360 is the whole way around the world. Let me skip 600 for a second. Let's go 165. How would we do a 165?
Quadrant 2.
Quadrant 2, closer to
180.
the 180 line, something like that. Might that actually be 160? Yeah, maybe, but we're not like that worried about super precision on this. Is anybody confused by what I'm trying to do with any of that? 200. Somebody other than Amelia, where would 200 land us? Quadrant 3, closer to the 180 line. So there goes 200 that way. How about negative 70? That's my first negative one.
Not possible.
See?
Not possible.
Yeah, where's it gonna go?
Oh, down instead of up.
Potentially, which quadrant would negative 70 land us in? Agree. Because instead of counting, this is still 0. What would it be if we landed here? Negative 90. Negative 180. Negative 270. Negative 360. We're just going in the other circle of direction. So negative 70 would be closer to negative 90. Let's go back to 600. What do you think about that? Anybody? 600? Where would 600 land? We can do it.
Quadrant 3.
Yes.
Closer to 270.
Yes. How do you know?
You subtract 600 minus like 360. and
Okay.
then
If you do a full lap of 360, where are we?
Back at the beginning.
Back at the beginning. So that first 360 is basically wasted. And you're worried about the other 240. Doing 600 is the same as doing 240, which would go there-ish, closer to the 270 line. Another way, I suppose you could have done that is keep counting by 90s. So if I go back to my picture over here, 360, if I kept counting, this would be 450. And this would also be 540, and this would be 630. This could be 720. Like it doesn't have to stop. We could go around and around. When you get into parts of degrees, this little punctuation mark is for minutes. Anybody have a guess how many minutes you think would be in a degree? If you do guess, you'll probably guess right how many minutes might be in a degree.
60.
60 is correct, just like there's minutes in.
An hour.
Same concept. So this is like 142 degrees, and then a little bit more. Like this would be like a little bit more than half a degree. Can we, in the sketches we're making, tell the difference between 142 and like 142 and a half? No, we're just ballparking these. But if they give you a part of a degree, that's just what this symbol was for. So don't worry about the 33, just worry about the 142. Where would we be headed for a 142? Quadrant 2, a little bit closer to the the 180 or the 90, a little closer to the 180, something about like that. Then here's another punctuation mark. If this one's minutes, what do you think this one is?
Seconds.
Seconds, how many seconds do you think are in a minute?
60.
60, okay. If we couldn't tell the difference, where the minutes would even take us, really, I mean, seconds, are we gonna be able to do anything with that, or, no way, exactly. So we're just worried about the 327. Where would 327 take us?
Quadrant 4.
Quadrant 4,
Closer to the 360.
a little bit closer to the 360, something like that. So that's about half the homework. About half the homework, there'll be a part A that'll say, draw the angle in standard position. We just did that. Okay. Keeping in mind, what we really just drew, if we were drawing a little bit more, is that one side of the angle was there, the other side of the angle is there, and we're measuring like how far we just rotated through Pac-Man there. Like we did about 327 degrees of rotating. Question about that?
So do the minutes and seconds like do anything?
Not really. I mean, not for your drawing purposes, no. It's just a way of describing, instead of saying it's like 142.5 degrees, that's a thing that gets used in different settings sometimes. Would it matter if you were like on a ship trying to head in a certain direction, whether you like steered the ship off by the minutes? It would, if you traveled like 1,000 miles. But in your homework life, no, it will do nothing really.
What if it was like 0 or 360?
If it were 0 or 360, something like that. That's all you could really do. Any other questions to that point? Okay. In the process of doing this, we accidentally bumped into a word that's good to know, but doesn't really appear in your homework life tonight. But sometimes you have two different angle numbers that end in the same place, and those are called coterminal angles. Can anybody spot on the board to this point some numbers that determine coterminal angles? Gio just asked about one of them. Well, the 0 is coterminal with
360.
360. Who else on the board is coterminal with 0 and 360?
90, 180.
Disagree. 0, 360, and one other number that's on the board is coterminal with 0 and 360.
720.
720. They all took us to that same spot on that first picture. Where's another pair of coterminals? 600 and 240. When we did this problem, 600 and 240 ended up being a match. That's true. There's 3 more that we've encountered.
90 and 450.
90 and 450, and in that same club later on the board went
270 and 60.
negative 270. Yeah, negative 270, 450, 90. They're all like north. Who all is west?
270, 630, and negative 90.
Those are south, but yeah, negative
Oh,
90,
sorry.
270, 630. Those are all headed south. Who's headed west?
180, 540, negative 180.
All true. Okay. Question about the concept of coterminal, how different numbers can take us to the same spot. So somebody tell me another number that 30 would be coterminal with. I know I shouldn't end a sentence in a preposition, but this is true. Not
390.
390. How did you do that magic trick?
Added 360.
Add another 360. Somebody else, play that game with me, get me another number.
Negative 330.
Say again?
Would negative 330 work?
Negative 330 would work. How do you do that?
You like went backwards.
Yeah, go back, so subtract 360. Let's get like one more from someone else.
$790.
That's
Negative.
warm.
750.
750, if we go positive, would be 360 more than that one. If we went negative, there is one that ends in 90, but not 790. If you go 360 away from that, headed more negatively, $690. Another thing I could say for these is that they differ by 360. If you just keep adding or subtracting 360, sooner or later you can make as many of them as you want to make. In the homework, there are some questions where they'll give you numbers instead of like 600, where we had an extra loop, they'll do like 6,000, where they went like around and around and around. And there's a quick way you can do that, but I'm not going to tell you until Monday. I'll give you something to look forward to, a little teaser trailer information. So there's a lot of ways you can figure out where 6,000 is. There is a quickest way to figure out where 6,000 is, but I'm going to hold that until Monday and see if you can figure it out and tell me. Question there? Here's a little bit of trivia, then I'll do my last section about reference angles, and then we're good for how to do this homework. Trivia information, our book will not very often do variables like X or Y. Those are out the window. For some reason in the world of trig, they like to do Greek letters. So we're back to like Euclid and all those guys sort of invented geometry back in the day. There's sort of a lot of Greek stuff going, and for some reason, Greek letters got entrenched in the world of trig instead of the normal to us letters. So when you see symbols like these throughout the book, they're just letters. You don't have to like super memorize these letters or something. If you copy the problem down and you just put an X because you're an American person and that's what you're used to, instead of the book doing these Greek letters, there's no harm in that. But this is the Greek letter theta. It's kind of like a zero wearing a belt. Alpha looks like a little fishy. Beta is basically like a bee that grew a little bit of a rat tail. Gamma is also a little bit like fishy-ish, just the fishy swimming downstream. Phi is the symbol you're more used to for the I can't do this problem, no answer, empty set kind of a symbol. Omega is more boring, it's just a W, but our book tends to use these for their variables, so when you see those, don't get freaked out over that. They're going Greek letters instead of English letters. The last little tidbit is on all the pictures you make in the homework, part A will be draw the angle in standard position, as we did. Part B will ask you to figure out how big and to mark a thing called a reference angle. The deal on the reference angles are they have to touch the x-axis, they have to be acute, and we're only going to do them as positives. So let me briefly just clear out my Pac-Man here. Okay, so on this, if I want to find the reference angle, I could go to the x-axis the short way, or I could go to the x-axis the long way. Based on the fact we have to be acute, I want to go right here to the x-axis the short way. It's all about the x-axis. So on this, here's the terminal side we drew. My closest path to the x-axis is to go down. Here, my closest path to the x-axis is to go up. My closest path here is up. From here, down. From here, up. From here, up. From here, down. And then we want to come up with a number for how much this is. This was 45. This was what number? 0. So how far apart are those? 45. Sometimes it is already the number we had. This was 320. What was this? 360. So how far apart are those? 40. This was 240-ish once we did the math. What line was this? 180. How far apart?
60.
60. You might be noticing a little bit of a trend. We're always going to have to, math-wise, subtract, and the only numbers that can come into play are either, come back to that. This, I'd subtract 165 with who? 180. And get
15.
15. This, I'd subtract 200 with 180 and get
20.
20. What are the only numbers that seem like they can really come into play?
0 to 80.
0 and 180, or maybe 360. Why can't these come into play? Where are we always going to go? Okay, so we can't use those because is that who on the y-axis? We're going to either subtract with 180 or like 0 or 360, whoever we're closer to. So this was negative 70. How far away are we from the x-axis? X-axis is at 0. We were at negative 70.
Oh, 70.
We're 70 away from going back home. Every one of these has to be acute. Reminder of acute means that it's
Less than 90.
less than 90. Has to be positive, has to be acute, has to be touching the x-axis. This one is going to go weird. Okay, 142 is trying to get to go touch, who's this?
180.
180. We're trying to do 180 minus 142.
38.
It is not. So I'm going to take a brief walk to the left because that'll be better for our camera purposes. If you were in elementary school and I asked you to do that, you would have to borrow. You'd make this be like,
179.
and this is a temporary pen that we borrow to become
9. 10.
You're going to have to like borrow to do that math. Okay, on this, we're going to have to borrow to do the math. We're going to have to borrow one of the degrees to create some minutes in a trade that's fair. What's a fair trade of 1 degree for how many minutes is a fair trade for a degree?
60.
60. 1 degree is a fair trade for 60 minutes. Just like over here, one thing in the hundreds place is a fair trade for 10 tens. One of our tens place numbers is a fair trade for 10 ones. One of our degrees is a fair trade for 60 minutes. And then we could subtract 60 minus 33
27.
is 27. Subtracting that
37.
is actually 37 because we borrowed. You don't always have to borrow when you get those minutesy ones. For example, if you have like 191 degrees and some change, and you subtract 180, can you do 27 minus an empty space? Sure, it's 27, and that can subtract to be 11. The borrowing only comes in if your empty space is on top of the minutes. Who was 327 closer to? It's 360. So we have to do 360 minus 327 minutes, seconds. If these minute seconds were on the top line, you would not have to borrow. But you can't have emptiness subtracting things. So we're going to need to take one of those degrees to leave 359 for a moment to make 60. However, we need to make this 59 to make 60 of those. Now we can do the math.
22.
22,
37.
37,
32.
32. And that's all we're doing. So there's a page 9 that goes from 1 to 34 that does just exactly what we did. They want you, part A, draw the angle in standard position. Part B, figure out what the reference angle would be, which is going to be subtracting either with 180 or 360, whoever you're closer to. Question about any of that?
What numbers was it?